audible, guys? Shall we start this session? Just do let me know. No? Uh, Drop something in the comment section. Is it fine? No? Okay, I hope I'm audible. So let us start this session. Okay, so in the last session we have been discussed about basics of rectifiers, and we are solving problems in source inductance. I hope many of you might be solved these questions. Chalo, just let me know what is the answer for this question. Just drop your answer in the comment section. I just wanted to know the answer for this question. Can you please do it? What is the answer for this question? The question that we are solving now. You can drop your answer. I just wanted to know the answer. What is the answer? Okay. Nobody? Chalo. See, let me try to solve this question. I hope you can understand. Let me try to do it first. Listen. Basically, what is the given in the data? What is the given data? Just collect the data from the question. Basically, they are talking about the effect of source inductance. In the question, they are talking about the effect of source inductance. Okay. So I just wanted to know whenever source inductance is given, what is the meaning of source inductance? Source inductance means with our AC source, anyway we are dealing with rectifiers, of course you all know. So rectifier means it is used to convert the power from AC to DC. Yes. So we are connecting this inductor with the input AC supply. So when the moment we are considering the effect of source inductance with what they told single phase fully controlled bridge rectifier, under this situation, what can be expected in resultancy? What they given, the effect of source inductance in single phase fully controlled bridge rectifier results in an equivalent resistance in series with the internal voltage rectifier. Voltage rectifier means it is the rectification process. We are using the rectifier circuits to rectify the supply because we are supplying AC, but I just wanted to know I just wanted to receive output as DC. So for that we are using this rectifier, that is what they told here. Now what is the equivalent resistance that has been? Okay, so this is the question, right? Any one of you got the answer for this? At least sir, we tried in this way and we got the answer like this. Anything? Anybody? No. Okay. Uh, the effect of source inductance with rectifier. It is results in an equivalent resistance in series with the internal voltage rectifier. Now let me tell you one thing here. What we have to know is we have to find out the value of inductance. Okay, sir. And then I'll just tell you what is the basic reason behind of this. First of all, the thing is whenever they are talking about equivalent resist, uh, guys, I think there is some mistake. Kindly replace it. See, I'm also explaining without conscious. Listen, what will happen is we will be connecting AC source with the source inductance. Kindly forgive me. There is some mistake in the question. So this is the circuit. So they are asking us to calculate the source inductance, equivalent source inductance, not source resistance. So change the question. Try now. Forgive me. There is some mistake. Equivalent inductance. It is in series with the rectifier circuit. Of course, it will be connected in series with the rectifier circuit. Rectifier circuit, we all know how our full bridge circuit will be looking like. After that, this resultant circuit will be directly connected with our load. This is the basic nature. Now we are supposed to calculate the value of this source inductance only, equivalent value of this source inductance. I hope many of you might know the formula to achieve this value. Now you can drop your answer. What it was given, what is the value of equivalent source inductance that we were requested to calculate here? Equivalent source inductance. They made some mistake in the question. That too only I can understand here. Okay, I don't know what kind of mistakes it has happened here. Again, they have given source inductance here. It is 2 millihenry, frequency is 50 hertz. I understood why you guys haven't given the answer for this question. Let me do research on it because I too don't know why they did this kind of mistakes here. Okay, chalo. Let us do one thing. Just keep this question with you. I just come back with the same question after some time because I should cross check what is the data that is missing in this question. I understood that something is went wrong here, but I don't know exactly what is the mistake that they have done here. Okay, chalo. Let us go ahead with the next question. Let me drop. Kindly listen to this question. I already told you why the questions have not been typed here. I know if we typed already it might save our time, but it is very important to observe the questions. So there is one more question. Once again, the given it is a single phase full bridge. They are given it is a single phase full bridge rectifier, full bridge rectifier with a source inductance Ls equal to 4 millihenry. Supply frequency is given as 50 hertz and supply voltage Vs, it is also given as 120 voltage. Everything is given. Is connected is connected connected with the load in such a way that output current output current denoted by I, I'm just using I, output current is continuous continuous. In bracket they told the meaning of this continuous. You all know continuous means that is ripple free, right? In such a way that the current, output current, they have connected, they haven't given any data about the load. They have connected this supply with some output circuit in such a way that the output current will become what? Continuous. Might be the connected load is taking responsibility to produce the continuous current, that is without ripple. You know the meaning of this ripple, without ripple. Ripple free means, you know, I have taken a very big lecture on it, right? So without ripple free. Now what they told is the value of output current I naught they have given, that is 10 ampere. It's little big value only, right? So that is also given. Okay, so output current is given. Supply voltage is given. Now the question is, find the V naught average. Find the value of average output voltage. Find the value of average output voltage. Okay, now you can take your time. Once again, take 2 to 3 minutes. Guys, just come with the same time. Delay வராதீங்க, it will not be effective, you all know. So you can take some 3 to 4 minutes. It's maximum time I'm telling. Take 2 minutes first to try to bring out the answer, because it is direct question. I hope many of you know the formula. Just to substitute all the given data into the formula. One more thing I forgot to given once again. Alpha equal to 45 degree. Firing angle is given. Just to substitute this. Yes, now you can start your start working on it. Drop your answer within 2 minutes. Okay, do it fast. First, collect all the given data. Write down the formula to calculate the V naught average. Substitute all the data, and keep smile in your face. Be active while solving the problem. Be conscious. Do it fast. Okay, you can use calci. Anyone? What is the answer for this question? Okay, Sugumari, 2 ampere. 2 ampere for what? The question is V naught average, right? Sumari ma'am, you told that your answer is 2 ampere. That is for what? Actually, the question is average output voltage is dash. Guys, be conscious. It's okay. Sometimes it happen. Maybe it voltage. It may be. See and be bold. Whatever the answer that you are getting, don't think about others. What other people are thinking about us. Just drop your answer. It doesn't matter whether it is correct or wrong. Every one of us are learner here. So learning the things. So don't focus on others. Don't be hesitate to drop your answer, whatever it is. It may be. Don't think that this is chilly. This is too good question. Kind of whatever it is, just drop your answer. 2 voltage. Okay, it's fine. Any other? Any other? Only one answer. Chalo, let's try it. Listen, basically, given it is a single phase full bridge rectifier with once again, given it is, they are considering the effect of source inductance. What is the beauty of considering the effect of source inductance? Let's see. So when we are considering the effect of source inductance, how basically it will be reflected in the output formula. See, it is not time to derive everything. I'm directly writing the formula, and this formula is most important. V naught average for a single phase full bridge rectifier when the output current is continuous. First, let me write down the formula for the V naught average when the output current will become continuous, ripple free. When current is ripple free, continuous conduction. You all know the meaning of continuous conduction. When the output current will become continuous with respect to time period, it means we have connected some kind of inductance at the output side. Output inductance. It will take the responsibility to produce the ripple free current. Under that situation, the output voltage V0 average for a single phase full bridge rectifier, the formula will become common. What is the generalized formula? 2Vm by pi into cosine of alpha. Yes, that is correct, sir. So this is the generalized formula that we all are supposed to. This is the formula that is what we are getting. It is not a thing that you have to memorize. Basically, if you derive current வந்து continuous outputல வருது அப்படின்னா அந்த டைம்ல நீங்க output voltage derive பண்ணீங்கன்னா this is the formula that you will be getting 2Vm by pi cos alpha. Okay, sir, that is exactly correct. We understood that. In that case, we can directly write, okay, sir, the formula will become 2Vm by pi into cosine of alpha. But I told here I haven't considered the effect of source inductance. This is output inductance. I have not considered the effect of source inductance. So in this case, directly you can substitute the value of alpha. Alpha they have given how much it is? Yeah, alpha is 45 degree. Okay, sir. And maximum voltage. What is the value of maximum voltage? Maximum voltage. See, if you observe, given it is source RMS voltage, yes or no? Always by default. Given it is RMS voltage. If given it is RMS voltage, how will you calculate the Vmax? We all know Vmax equal to square root times of Vrms. Yes, sir. That is we all know. Now, what is the value of RMS voltage? Given it is 120. So, root 2 times of 120. Now, we know all the data, you can substitute and it will always, it will be immediately give you the value of V0 average. But I told I haven't considered the effect of source inductance. Yeah, that's fine, sir. Suppose if we are considering the effect of source inductance, how do this what is the changes that we will be facing in the same formula? See, in the first part, there will be no changes. As usual, it will become 2Vm by pi into cos alpha. Absolutely, there is no changes in this value. Minus, what we are going to get is, take this same factor 2. I'm just typing here the way that you can easily remember. See, first take this same 2, type it here. Same pi, type it in the denominator. Now, what you have to do is, instead of keeping this, it is voltage, right? It is voltage. We know this voltage can also be written as, in the input side, if you observe, we have the source inductance. When we want output voltage, input side, if you observe, in the input side, we have the source inductance. How will you calculate the voltage drop across the source inductance? According to Ohm's law, it will be V is equal to I into XL. But here we are calculating V0 average output value. So here the current that I'm going to consider is output current. Just to put output current here. After that, replace this XL by, only consider the magnitude. I know XL can be replaced by J into omega L, but I just wanted to know the magnitude of this inductive reactance. So you can keep I0 into omega L. L is what? That is source inductance. Now, if you substitute that value here, how this formula will get changed? Now, I am writing it here. So, the value of V0 average can be beautifully written as, without inductance, you know how to write. It can be written as 2Vm by pi into cos alpha. With the source inductance, I have to put minus. I'm just subtracting the effect of inductance here. So minus, just I have to put same 2 by pi. Now in place of V, according to Ohm's law, V is equal to, we are substituting, V is equal to I into XL. I is what? Output current. XL can be replaced by omega into various L is with the source inductance, right? So you have to consider the effect of source inductance. See how easily I have written the formula here. This is not the way. I'm just writing the way such that you can remember it easily. Now hereafter you won't be forget this, right? So it is very easy to write. Okay, sir. Now observe. I hope all the data is given in our question in a beautiful manner. What they told, maximum voltage is clearly given. That is root 2 times of RMS voltage. Yes, sir. Into cosine of alpha value is clearly given. That is 45 degree. It's a direct question. Minus 2 upon pi. Output current, I think it is 10 ampere, right? Yes, it is 10 ampere. So you can directly substitute that value into omega. See, basically this omega can be rewritten as 2 pi f. Can I write like this? So 2 into pi into, what is the value of f? 50 hertz frequency. It is given, right? Source frequency, it is 50 hertz. Okay, sir. Then what we have to do? Into source inductance. Source inductance also given, that is 4 millihenry. See that, just to substitute. So it is 4 milli means 10 power minus 3. Now see there, this pi will get cancelled out. Yes, sir. Then 10 times of 5. 50, 10 times of 50 will be 500. Absolutely. 500 times of 4 will be 2000. 2000 into 2 will be 4000. 4000 into 2 will be 8000. 8000 into 10 power minus 3. 8000 into 10 power minus 3. 8000 can be written as 8 into 10 power 3. 10 power minus 3 into 10 power plus 3 will give you 1. So 1 into 8 will become, finally this net value will be replaced by 8 simply. Yes, sir, it is. Yes, it is. So now let us reduce this part. 2 by pi into root 2 into 120 into cos 45. What is the value of cos 45? I hope it will be 1 by root 2. Yes or no? It is 1 by root 2 only. So root 2 will get cancelled out. Minus, don't forget, we will be having 8 here. Okay, sir. Next, here, let us reduce as much as possible. 2 into 120 will give you 240. Yes. So 240 upon pi minus 80. So up to this step, you have to do it by your hand only. Because whenever you are writing, what you people are doing is directly you guys are taking the calcium and typing all these values. Do you know what will happen? When the moment you people are directly trying immediately in the next step by keeping these many numerical values, there may be a chances of missing the values, or there may be a chances of substituting wrong values. So it may leads to wrong answer. In the examination you will have certain fear. Basically it will be removed, you have to practice for that, but during that what I can say, there will be some little frustration, a little fear, and you will be doing we have time, we have no time, we have only 2 hours. This kind of it will like somebody is admitted in the hospital during the pregnancy. ப்ரெக்னெண்ட்டாக இருக்கும்போது லேடிஸ் அட்மிட் பண்ணுவாங்களா, அவங்க கத்திட்டு இருக்க மாதிரி நம்ம அங்கே ரியாக்ட் பண்ணிட்டு இருப்போம். ஓ மை காட், ஓகே இட்ஸ் கோயிங் டு பி எக்ஸாம் முடியும். தட் ஃபியர் அந்த டைம்ல என்ன ஆகும் அப்படின்னா, டியூரிங் தட் டைம் இஃப் யூ ஆர் சப்ஸ்டியூட்டிங் திஸ் கைண்ட் ஆஃப் ஹோல் வேல்யூஸ் இன் தி calcium, it may be lead to wrong answer. So avoid, in order to avoid these things, try to minimize these steps as much as possible just with the help of your brain. Now you can simply substitute 240 by pi, you'll be getting some value minus 8. If you get, see, I'm getting almost 68.394 voltage. See how simply we got the answer. That's it, it's over. Now it's just remember this formula, it will be helpful for you at many cases. Because see there, now I will tell you one more logic. If you observe, I can write like this V naught average can be written as, just let's make some points here, it will be helpful for you. What we can do is, see, this is V naught average with the source inductance, so I can write V naught average with the source inductance. If you observe the right hand side, this 2Vm by cos alpha can be replaced by V naught average without source inductance. So I am not putting Ls. Ls means with the source inductance. If I will pass, see, I am replacing this 2Vm by pi cos alpha by V naught average without source inductance. We know this is the generalized formula to calculate the output average value of a single phase full bridge rectifier without source inductance. So when I am writing in this way, I'm just willing to pass it to the left hand side such that this can be written as V naught average with the source inductance minus V naught average without source inductance equal to, we can write 2 pi into I naught into omega into Ls. Okay, now see there, V naught average with the source inductance, V naught average without source inductance. This is called a difference between these two voltages. This voltage is called ripple voltage. So del V naught, the difference between output voltages. If I will consider the effect of source inductance, what will happen? If I will not consider the effect of source inductance, what will happen? See, just we are subtracting with the source inductance, without source inductance. That resultant will give you the ripple in the voltage when we are finding the difference. So this will be called as simply del V naught equal to, I can write 2 pi into I naught into omega Ls. So in some other question, what people will do is they will give you the value of del V naught, they will give you the value of omega I naught, you will be requested to calculate the value of source inductance. These kind of questions also will be framed. Similarly, they will give you the value of source inductance, they will give you the value of I naught, you will be requested to calculate the value of del V naught. So it is easy to remember all these formulas. Anyway, it doesn't matter what type of question that will be asked in your examination. Yes or no? Yes. So we can simply write the expression in this way. Geeta Vm, sir, is not del V naught equal to omega L I naught by pi. Sorry, ma'am, what you are asking? I'm not getting you. You're trying to say something. There is any mistake in the formula. 2 is extra coming. You can cross check. I do also cross check. This is the basic derivation, begin of that. It's okay, no issues. We can cross check. Okay. So just you do remember this is the way you have to bring the ripple in voltage. Okay. That's all. Okay, sir. Fine. So with the source inductance, remembering these formulas are a little bit helpful for every one of you. So try to remember it. It will be useful. Fine. So guys, cross check. They are telling that this 2 is coming extra. I do. It's very long time. I have to derive the derivation. You can just recollect it once. If it is not there, just remember it. How the way to keep these things in your mind. Okay. Fine. So let me drop out the next question. The next question is write down once again. The question is in a single phase full converter. If in a single phase full converter, okay, in a single phase full converter delivering an output delivering an output ripple free delivering an output ripple free load current as usual same data ripple free load current of 20 ampere. Yeah. So the question is the average value of thyristor current in ampere is dash. The it's easy question, right? Average value of same question. I think thyristor current. The average value of thyristor current is dash. We might have seen this type of question already, so don't take much time. Drop it immediately. What is the average value of thyristor current? We saw already. It's a kind of repeated question. I don't think it will take much time. You can drop your answer as speed as possible in the comment section. I'm writing the next question. Anybody? What is the answer? Don't take much time, okay? Because you all know we are always started playing with our circuits. Yes. அப்படியே மைண்ட்ல ஓடணும். ஓகே, இப்படி நம்ம பார்த்தோம், அந்த மாதிரி பார்த்தோம். That much of practice is required. Okay, how many of you got the answer? Geeta 10, Sukumari 10, Mageshwari. Good, good, very good, very good. What about other people? I'm expecting answer from every one of you. Just drop your answer. Okay, I hope every one of you got the answer. See, this last question already we have been discussed. There is no big things. I have drawn the way from everything I did already. So Kanaga Savita, good. Same. See, it's very good. I told now. What is the relation? The average value of the thyristor current. Average value of the thyristor current. We got the relation. That is simply equal to output current I naught upon 2. And we also tried to figure out the value of RMS value of the thyristor current. What we got, it gave the relation as I naught upon square root of 2. Do remember these things. See, I am not forcing you people to memorize, But here whatever the things that I am dropping, they are very important. See there, see in the same formula data are getting repeated or not. Once again same question we are facing. Now take the next question. What they told is a single phase fully controlled bridge rectifier with the data. They told 3 diodes, 1 thyristor. It's a beautiful question. And source voltage they told 120, frequency 50 hertz, and they are firing this one thyristor. See, okay, these things you can think. I don't want to tell everything. Alpha is given. RLE load. Actually, it is supplying RLE load, whereas the value of E, L, R, everything is clearly given. The question is identify the power absorbed by the load battery E. Actually, the question is E denotes the battery. Question is identify the power absorbed by the battery. That's all. I hope you understood the question. If you don't understand, rewrite one more time, reread the question. I just wanted to know the answer. What is the power absorbed by the battery? Take your time. Okay, you can take 3 to 4 minutes also. I'll be waiting. But it's a completely training session. If you want to get all India rank in any exams that you are going to write, try to strive your brain in a correct direction. Okay, be conscious, keep smile in your face. Serious ஆ எதுவும் ஆப்ரேஷன் பண்ணாதீங்க, just keep smile with the face. Do it actively, step by step, fast ஆ பண்ணுங்க. துரு துரு துருன்னு நம்ம செய்வோம் இல்லையா, சொல்லுவாங்கல்ல, you have to do it that way. Just do it as speed as possible, but being conscious is very important, because when the moment we are rising this speed without conscious, automatically mistakes will happen. These mistakes will come only when you people don't have conscious. If you are doing anything at fast with the conscious, nothing will happen. So do it with the conscious. It doesn't matter how fast you are doing. It's all about is how consciously you are doing, such that it will be highly accurate. Chalo, what is the answer? If you don't know how to bring the output things at all, you can try draw the given circuit. How to draw, you know how to draw single phase full bridge rectifier, and just connect on AC output, AC source from the input side, and then keep 3 diodes and 1 thyristor. You can keep thyristor at any place that you want. There is no restriction for the place of the thyristor. You can keep it anywhere that you want. Okay, and try to derive the output expression for this. I hope you will be getting the answer. So if you have any doubts, sir, where to keep thyristor, I will be keeping. You can treat thyristor in the place of T1. You can keep thyristor such that at remaining all places keep diodes. You know how to draw the full bridge rectifier. Will be this is the way we are drawing the circuit, right? Then you can keep the load here. Yeah, it's a beautiful circuit, right? So do it in this way and try to bring the answer. Yes, I'm placing it here. Remaining all are diodes. Now you can name it diode D1, D2, whatever the way that you want, you can do it. It's completely your choice. Bring the answer. Try to bring the answer. Okay. Shall we try? See, that's why I told you in the first 2 sessions also, I requested every one of you, whenever, suppose if you are facing any new circuits, you will be suddenly struggled, because when we started memorizing everything and loading into your brain, while when the moment you are facing something new, you will be struggle, you will be in struggle. But here in this case there is no point of struggling, but you can derive it. See what will happen. What they told is they have taken one single AC source. Yes sir, let me keep one thyristor here. Okay, in the same leg, in the lower leg I'm placing on diode. Let me take one more leg. In that leg I will be placing one more diode, sorry, upper leg I am placing diode. Of course in the lower leg also we are going to repeat the same thing as per the given data. Then they told clearly output is R L E load. If it is given as RE load, then that will be considered as the equivalent circuit of DC machine. Don't forget. Given it is RLE load, if it is given as RE load, what is that? That is the equivalent representation of DC machine, because you all know the equivalent circuit of DC machine. Though you haven't studied here in our semester exams or somewhere you might be see that circuits DC machine. Fine, sir. So let's give some name, diode thyristor and diode D1. Let me name this diode D2 and diode D3. Okay. The value of resistance is given as 10 ohm. I hope it's correct. Let me cross check. Yes, it is 10 ohm. Inductance is 10 millihenry. And the value of battery voltage, yes, it is 100 volt. Fine. So everything is given. If you observe the supply voltage is 120, yes, of course it is 120 RMS voltage. Fine, sir, everything is given. Anything else to keep? That's all. So the only thing that I should keep here is the value of alpha equal to 30 degree. Yes or no? Fine. So let us start the operation. So from the input side we will be injecting AC sinusoidal with respect to time period. I'm going to inject one purely sinusoidal waveform. Yes, it is injected, and you all know its period. It will be 0, 180 degree and then 360 degree. Yes or no? Yes, sir. This is input voltage. Let's see what will happen. You guys have to tell me. See, first let us keep our attention with the positive cycle, then we will be keeping our attention with the negative cycle. So for that I just wanted to draw some dotted line in order to show the clarified waveform. Yes, so let me draw one more line here. So here I'm expecting it to be a beautiful one. Let's see what will happen. Sir, here in the positive of, you can observe there is one thyristor T1 and there is one diode D3. You know which things will turn on. How will you analyzing this? Positive means this one is going to be positive and this is going to be negative. So immediately this positive will come here, it will go. Then it will be reaching this thyristor. By default, opposite is going to be negative. If you observe, same positive will come here also. This is also going to be positive. By default, opposite is going to be negative. Similarly, if you observe, this negative will go here. Yes, it will be traveling. Then it will be jumping from here because there is no direct connection. Then here, if you observe, this negative will be reflected here. By default, opposite is going to be what? Positive. Same negative will be reflecting here. By default, opposite is going to be positive. Now you can guess. Sir, if you are having a diode, when the moment I am having a single diode, in order to turn on the diode, only one condition will be satisfied. Sufficient. What is that condition? Whenever the value of anode voltage will become greater than the value of cathode voltage, this diode will immediately turn on. We can short circuit. Yes, of course, it's correct. Okay, sir. Under this condition, when I'm looking into the diode, I'm really very happy. See, now you have to tell me there are three diodes. Which diode will going to turn on now? If you observe diode D1, anode is having negative, cathode is having positive. So cathode voltage is higher than the value of positive, anode voltage, so it will not turn on. Similarly, diode D2 also will not turn on. But when I'm looking into D3, yes, definitely it will turn on, sir. Why? Because anode is carrying positive voltage, cathode is carrying negative voltage. So the value of anode voltage is higher than the value of cathode voltage. Definitely this diode will turn on, so we can short circuit it. But when we are focusing into the thyristor, okay, sir, now I'm very happy that one thyristor will turn on. But the problem is whether the power will get transferred from the source to load or not. No, just by enabling this diode D3 alone, you cannot transfer. There is one more supreme star is waiting here. That is our controller, thyristor T1. For the thyristor T1, one condition is satisfied. You all know thyristor, basically it is called the SCR, the silicon controlled rectifier. This supreme star always demanding two things. One is we must satisfy the condition number one, that the value of anode voltage must be greater than the value of cathode voltage. And the second condition, we must inject some gate current such that this thyristor will turn on. So immediately, yes, I am going to inject this gate current. It should not be equal to 0 when the value of alpha will be reaching out the value of 30 degree. It is given in the question. So we have to wait till the value of theta will become equal to 30 degree. That is the value of alpha. That is the point when we are going to inject the gate current. So immediately this SCR will get triggered. Once it is turned on, then what will happen? So thyristor T1 and diode D3 will get a turn on at 30. See, diode D3 is already in conduction, but it is not able to. It is what? It is ready to conduct, but we are unable to. It is unable to carry the current due to the absence of thyristor T1. It is blocking. It's acting as a open circuit till the value of alpha become 30 degree. Then the value of theta equal to 30 degree. So after that, immediately this input waveform, this portion will get reflected in the output till the first 180 degree. So if you draw the waveform, it will be like this. So it will be going, yeah, approximately I just assume it as a sinusoidal waveform. Okay, I know it's not looking good. So next, okay sir, it's fine. In the positive half cycle, everything is fine. In the negative half cycle, we have done. In the negative half cycle, polarity of the supply will get reversed. Now again do the research. Very first time when you guys are doing this, I know it might be taking a little long time, but it is not the case every time. What will happen is continuous practice will help you to understand the operation. So after some time, just by looking into the circuit, you will be directly drawing the waveform. Of course, you will be directly writing the output expression. That much is fast speed will come when you are continuously doing the practice. So it depends on how much effort that you are putting. Okay, so let's reverse the operation. Let's see what will happen when the moment I'm trying to reverse this case. Reverse the case means what? Second cycle I have to draw the waveform. Yes, sir. So I reverse the polarity. Now what will happen? This positive will come here, and it will jump and it will go here. Now, if you observe, this is positive, by default opposite is going to be negative. Yes, this will come positive, by default opposite is going to be negative, sir. Of course, it's true. It's true. Okay, here I forgot to draw one more thing. See, we haven't considered the effect of battery voltage. Kindly forgive me. What we have to do is we have to calculate the value of guys, do one thing, change the question, remove this battery, because I forget that they given the value of battery here. See, this is unconscious. Remove this value of battery. Next question we will be dealing with this battery. Now what we are going to do is just we are going to find out the output power absorbed by the load. Because I haven't considered the effect of battery, then again I should start from the beginning. Instead of that, we will be just traveling along with the same circuit. Forgive me. Okay, fine. So let us go ahead with the next case. Anyway, it doesn't matter whether the output is E or not. Your output voltage expression will become same only. I will be writing the expression. After that, for the RLE load, you can do it by your own. Manually, you can do it. Let me draw. Whenever we are having 3 diodes, 1 thyristor, how the output voltage will get reflected here. Okay, without E, I'm repeating, I'm not considering effect of battery. Remove it first. Okay, I did a mistake, I haven't observed it. Fine, sir. Okay, in the second cycle, what will happen? Now, once again, you can observe when polarity will get reversed, diode D3 will be immediately turned off and thyristor T1 too. This is also will going to be turned off because the polarity will get reversed. Okay, sir. Under this situation, if you observe, when the polarity will get reversed, yes, sir. If the polarity will get reversed, then thyristor T1 will going to be turned off because of the polarity reversal. At the same time, what will happen for these diodes? See, this will become negative, and diode D2, if you observe, minus and plus. Yes, Sumari ma'am, you are correct, but I haven't considered that. I haven't noticed that E. Okay, fine. Let's carry with the RL load. Then again, we will come back to RLE load. No issue. Okay. Fine, sir. Now tell me whether the diode D1 and D2 will be turning on or not. Yes, of course, definitely diode D1 and D2 will turn on. It will turn on, obviously, undoubtedly. There will be no doubts, first of all. There will be no doubts. So, okay, sir, everything is fine. Now, the question will come here. What is the question is, sir, if you observe, there is one inductor. When the moment we are considering the effect of R and L, I hope you all have remember, even in thyristor circuits also I told you, whenever you are considering the effect of inductance in the output side, it will continuously charging for the whole positive duration. So when the moment it is continuously charging, when you are reversing the polarity of the supply, the amount of energy that is stored in the inductor will not get discharged instantly. So what will happen when we are comparing this positive energy with the supply negative energy? This energy will be more. So what it will do is it will again continuously it will push this thyristor T1 to continuous its conduction. It will force the thyristor to continuous its conduction. Okay sir, till what end it will continue its conduction? It will be continued till the next firing angle will appear. But the problem is, what you have to observe here is, your inductor will start freewheeling up to certain time period. But what is the time period? What will happen here? See, if you observe carefully, the amount of energy that is stored in the inductor will forcefully. It is when we are comparing this positive energy with the supply negative energy, this inductor energy will be more. Okay, sir. So what it will do? Just observe. If you are focusing it, if positive energy is higher than the supply negative energy, then automatically for a particular duration, it will maintain the same previous polarity that we have been observed previously. Previously means what? Before 180 degree, whatever the polarity that you have been observed across the devices, same polarity will be continued for only some particular time period. Because of this positive energy, it will be acting like this. So when the moment you are comparing this negative with the inductive positive energy, here it will become plus only again. So here it will be minus only. Why it is happening? Why? Because the positive energy stored in the inductor is higher than the value of negative energy offered by the supply only for the particular time period. Sir, அப்ப என்ன நடக்கும் அப்படின்னா, if you observe carefully, under that situation your circuit will get, once again, it will be continuing its conduction for a particular time period, and you can observe these. It waveform will be continued only for particular time period, and you can assume that till next to 30 degree, after 180 degree. After that, what will happen? After that, the once this full energy is slowly, once the energy will become less than the value of the supply voltage, then your new polarity will appear. Then diode D1 and D2 will turn on. Again, you can observe the second cycle positive polarity. See, though your input is negative, what I have been told you, after reversing the polarity, see that this positive polarity will be traveling through this diode and it will be reflected once again across the output. The switching arrangement that we are doing in the rectifier circuits will maintain the continuous positive polarity. So then why we are getting this negative in the output side? Did you observe this negative supply? This negative portion will get reflected in the output due to the presence of inductive load. After that, same, once again what will happen is positive voltage will be appearing here. Then once again, after 360 degree, if you observe this circuit, after 360 degree, what will happen? Same cycle will get reflected. So during this period, once again inductor will be charging. There will be continuously force the diodes to continuous its conduction. After that, next thyristor will be turn on once again after 360 degree. So same waveform will get reflected. Now I hope you got the clarity how to draw the waveforms. First of all, when the presence of inductor, when we are considering the effect of inductor in the output side, it's actually a beautiful thing. What will happen is, so if we are considering the effect of source inductance, what will happen? Sorry, this battery. If you are considering the effect of this battery, what will happen? Let me tell you the second logic. Let us enter into that concept. Anyway, it's unfortunately we have been discussed about the effect of inductance. Okay, sir. Now the second case. Suppose if you are considering the effect of battery, what will happen is this DC battery is continuously connected with the inductor. So you all know, when an inductor is connected with a DC supply for a very long time, what will happen? It will be acting as a short circuit. So it will be automatically short circuited. You cannot see its effect in the output side. It will be there definitely, that charging effect, discharging effect, everything you can observe, and the inductor will absorb some energy that will be stored there. Everything will be fine. But what will happen is, due to the presence of DC supply, inductor will be behaving as a short circuited one. It will be fully charged with the help of this DC supply. It will be fully charged and it will be present there. That's all. This is what will happen. Okay, sir. Now, if we are considering the effect of battery, what will happen is, when the moment you are calculating the V0 average, now you know how to calculate the value of V0 average for this. Now I am requesting you to do the V0 average calculation for the RLE load. See, I don't think it will take much time for me if I will draw. I will just show you. Basically, if you observe our lecture, there I have done this clearly. So we have to consider the effect of battery with our sinusoidal waveform. Then you know this is the point where the output DC supply and the input AC will meet each other. So under this point, if in the question alpha is already given, I have already clarified in the starting itself. I told alpha equal to 30 degree. Now you have to calculate the value of theta at this point, because this DC voltage will be reflecting across the cathode and this AC voltage will be reflecting across the anode. Now at this point you have to check two conditions need to be satisfied. One is if VA is VK, VA is greater than VK, and this is the first condition. And second condition is if the value of alpha is not equal to 0. Alpha will be triggered. We are giving the gate current. Gate current will become not equal to 0 from alpha equal to 30 degree onwards. So this condition will be satisfied from alpha equal to 30 degree onwards. Now you should check whether the value of VA will become greater than VK or not. These things can be, it can be proved only when you are checking. When the value of anode across the anode, you will be having Vm sine omega t. That omega t will be replaced by theta. That is the point where the value of Vm sine omega t will become equal to the value of E. So from this you can say theta equal to, after this point, immediately after this point, we know the value of anode voltage will become greater than the value of cathode voltage. So I can write it will be sine inverse of 100 by Vmax is root 2 times of 120. You all know. Now reduce this, calculate the value of theta. Anyway, I will be doing for you people, then it will be easy for you guys also. You can easily solve it. If we do this, then you will be getting the value of theta. See, the value of theta will be equal to 36.10 degree. Do you remember? We have been solved very few problems. There, I told you if the value of alpha is not given in the question, that is the first question. If alpha is not given, if alpha is not given, then by default you can consider the value of theta equal to alpha. And the second case, if the value of alpha is greater than the value of theta, then thyristor will turn on. Thyristor will turn on only when the value of fire. So you have to consider this is your firing angle. This is the point where thyristor will turn on. Suppose if the value of theta is greater than the value of alpha, then theta is the point where thyristor will going to turn on. You should not consider immediately, sir, alpha equal to 30 degree, here itself thyristor will turn on. No. So now this firing angle, now what is the firing angle? Theta will be acting as a firing angle. This alpha you should ignore. In our question, they have given the value of alpha equal to 30 degree. They are triggering the thyristor, but thyristor is struggling to turn on. Why? Because the value of theta, till one more condition is not being satisfied, that the value of anode voltage will not become greater than the value of cathode voltage. These things will be happening when we are reaching the value of theta equal to 36.16 degree. So, but actually, basically, this is my own data. In this question, I have given my own data. In most of the questions, either alpha will be given or alpha கொடுத்திருப்பாங்க, alpha கொடுத்தாங்க அப்படின்னா first condition, this condition will be satisfied. Alpha will become greater than theta. So, directly நீங்க alpha கொடுக்கும்போது turn on ஆயிடும். Another case is alpha will not be given. So, by default, you can take theta equal to alpha. So, by considering this, what you can do? Now, you can turn on the SCR and draw the output waveform. So this output voltage will be following input supply till once again when the value of VA is continuously greater than the value of VK. In the condition satisfied ஆகிற வரைக்கும் this waveform will be continuously existing. After that DC will exist. Again same structure will get reflected in another half cycle also. Okay, so see, don't think too much. This all things I have clearly explained step by step in our lecture. So here, instead of wasting the time, I am directly writing the formula. Whenever a 3 diodes will be given with one thyristor, so what you will be getting is the value of V0 average for the full bridge rectifier will be coming Vm by 2 pi into 3 plus cos alpha. Just note it down. If you derive the expression, then also you will get the same answer, because here unfortunately due to lack of time I am dropping here because it is training session. I can't keep everything here, but what you can do is just to collect the data and simply drop this. So whenever average value, that is whenever we are considering 3 diodes with a single one thyristor, then the V0 average will become Vm by 2 pi into 3 plus cos alpha. Okay, okay sir, fine. Now you can substitute all the values. Alpha is given as 30 degree, substitute that. Okay, wait, you can substitute the value of alpha here now because wait, in our question what is the given data? கவனிங்க நம்ம கொஸ்டின்ல என்ன சப்ஸ்டிட் பண்ணா alpha equal to 30 degree you should not substitute. Alpha equal to 36.16 degree you have to substitute. Why sir, why should I? Alpha questionல already கொடுத்திருக்காங்க, but you are saying that don't substitute this value. Why? Because I told the value of theta is greater than alpha, so thyristor will not turn on at this point. இப்போ நீங்க b naught average க்கு direct alpha equal to 30 degree substitute பண்ணீங்கன்னா your answer will be wrong. So cross check whether the theta is greater than alpha or the value of theta is less than alpha. This is very important to know whenever you are trying to solve the problem. Now Vm, you know, it will be root 2 times of 120, substitute all the values. And then the value of alpha is 36.10 degree, substitute that, you will be getting the value of V naught average for our question when RLE load will be appearing. If only RL load will be appearing, then how to draw the waveform? See, if you are not understanding, sir, I literally don't know how to draw this. You can just go through the lectures. First R load, how to draw the waveform, RL load, how to draw the waveform. Do it by yourself. First observe how to do, then try it by yourself. Compare your answer with the given lecture, such that automatically you will be understanding how to draw the waveform. This training will be helpful for you. Okay, fine. Chalo. We will be going up with the next question now. I hope you understood this. Just substitute all the data you will be getting. If you want to know the answer, I will be doing root 2 into 120. You will be getting 169.7 divided by, you have to put 2 pi. You will be getting 27. So what you have to do is now 27 in bracket. We got 36.1 for the value of alpha. Then take cos for this. So you'll be getting some radian value, added to 3, then multiplied with the 27. You'll be getting 102.81. So the actual V naught average for the above given question is 102.81 5 voltage. So this is the value of V naught average. Now what is the question? So they have asked. So they have not only asked this question, right? Wait, I think yeah. Actually, the question is, what is the power absorbed by the battery? How will you calculate the power absorbed by the battery? Let me tell you. There is one resistor. Yes, I am neglecting the effect of inductance because you know the reason. And where we are observing the output voltage? This whole portion. Here we are observing the V naught average. So here output current will go in this way. Just apply KCL and sorry KVL. This is resistor R and battery E. Now I just wanted to know the value of I naught. How will you do that? See there. If you consider only resistor alone, this resistor will be having two terminal. In one terminal I am having V naught average. See, this V naught positive voltage will be reflected here. V naught positive value. Then the current will be going like this, I naught. In another terminal I am having the battery positive terminal will be reflected here. We saw in circuit theory all these things. Now how will you calculate the value of I naught? To know the value of I naught, we must know the voltage drop across this resistor. How will you do that? According to potential difference. What is the basic definition of voltage? Potential difference between the terminal will give you the voltage drop across any element. So terminal of the resistor will be carrying V naught and E. We know the value of V naught is always higher than the value of E. So V naught minus E. Direction of current is clearly telling. And one more thing. When the direction of current is going left to right, it means what? Current always directed from higher potential point to lower potential point. So you can simply consider V naught minus E divided by R. You will be getting the value of I naught. Now the value of battery is already given. The value of battery is given as 100 voltage. And just now we have been explored the value of output voltage. I hope it will be 102.81. I think this is the correct answer from my side. So we know the value of V naught and battery both. So calculate the value of output current I is equal to 102.81 minus 100. It will be 2.81 upon resistor value is 10. So it will be 0.281 ampere. Now we know the value of current. We also know the value of voltage. Calculate this. Which voltage you have to consider? Not this one. Power absorbed by the battery. What is the value of battery voltage? It is 100. What is the current consumed by the battery? It will be 0.281. So the formula will give you the value of 28.1 watts. So we found the value of answer. So in this lecture, So for in this problem, we understood first of all, if RL is given, then how to draw the waveform. If RE is given, I had given it as a homework. Anyway, I had given all the concepts, how to draw it. So basically, whenever they are giving a full bridge rectifier with the 3 diodes and 1 thyristor, directly you can write the V naught average formula as what? 2 Vm by pi into 3 plus cos alpha. So by writing this formula, you can directly, sorry, Vm by 2 pi, see, sometimes I'm also confusing. It's a gap. That's why we should continuously practice. I know it will be Vm by 2 pi into 3 plus cos alpha. Okay, there is a difference. Because here we should take a 360-degree rotation. ஏன்னா நமக்கு என்ன கிடைக்கும் அப்படின்னா first 180ல உங்களுக்கு கிடைக்கிற waveform வந்து different-ஆ இருக்கும், second 180ல கிடைக்கிற waveform different-ஆ இருக்கும். So you cannot consider only one 180 degree. Basically in single phase full bridge rectifier, outputல வந்து என்ன ஆகும் அப்படின்னா ஒரு 180 degree மட்டும் தான் consider பண்ணுவாங்க. But it depends on the load. We cannot consider always like that. In this case, when the nature of the cycle will be repeating after every 360 degree. இப்போ ஒரு waveform வந்து இந்த மாதிரி வருது, ஃபுல்லா வருது, அதுக்கப்புறம் கொஞ்சம் தான் வருது, திரும்பவும் கொஞ்சம் தான் வருது, ஃபுல்லா வருது அப்படின்னா for each and every 360 degree this waveform will get repeated. Appo you have to consider the 360 degree. Suppose if the waveform will be like this, first 180 degree, whatever the waveform that is I am observing, same waveform will be in the next 180. Same next waveform will be next 180. In the mari vanduchu appadina, when you are observing same pattern for each and every 180 degree, then the duration of the cycle will be 180 only. If you are observing two different pattern for 360 degree, ஒரு 360 degree குள்ள first 180ல ஒரு மார் இருக்கு, அடுத்த 180ல ஒரு மார் இருக்கு அப்படின்னா, then you have to calculate for 360 degree, you have to consider the total waveform, then it will get repeated. Like that you should consider. So in this case, whenever you are considering 3 diodes, 1 thyristor, as I told you that first 180 degree your waveform will be different, another 180 it will be different, so you should consider 360 degree, such that you will be coming up with this answer. Okay, I told all the procedures, just follow it and keep these things in your mind. It's better always try to learn how to draw the waveforms. I am repeating. Chalo, single phase we have completed almost, so let us enter into 3 phase. Next question. A 3 phase, write down the question. Fully controlled converter. A 3 phase fully controlled converter is employed to charge a battery. It is charging a battery. Simply I can say it is employed to charge a battery. It is employed to charge a battery with the voltage of battery voltage is given. The value of the battery voltage is 95 volt. It is charging a 95 voltage battery. And the internal resistance of the battery is given. Battery internal resistance is 0.2 ohm. It is also given. Now what they told is the supply RMS voltage. Let me write directly. Supply RMS voltage is given as 240 volt. That is also given. And they told this is line to line voltage. They are measuring this. Sorry, line to neutral voltage. Phase voltage is given. Guys, this is line to neutral. Neutral means you know that is phase voltage. It is given. And the output current I naught, they told it is 50 ampere and it is constant. In bracket they told this current is constant. Output is DC, right? Yes, so this current is constant. Now what is the question is, what is the power factor? The question one is, what is the power factor of the supply? Supply power factor is dash. That is the first question. And second question is firing angle alpha equal to dash. That's all. These are all the two questions that you have to solve now. Okay, take your time and drop your answer. V naught formula valid for RL load, sir. RL load ko different aguma. Yes, Sugmari ma'am. RLE I have written any that formula is general only. The formula that I wrote here, battery number only. This formula is RLE load. In both cases you can use this formula, but make sure whether the current is continuous. Okay, because in your question நம்ம லாஸ்டா சால்வ் பண்ண क्वेश्चनல வந்து they haven't given the data as usual. அவங்க என்ன சொல்லியிருக்காங்கன்னா just we have to estimate the value of power அப்படின்னு மட்டும் கொடுத்துட்டாங்க. So with the given data, by default I am assuming that the current is in a continuous conduction. Inductor is charging, again discharging, charging, discharging. அப்ப என்ன ஆகுன்னு பார்த்தீங்கன்னா நம்ம wave form வரைஞ்சோம் இல்லையா? See there, if you observe, நான் wave form இப்படி வரைஞ்சேன். RL லோடுக்கு நான் அவுட்புட் வோல்டேஜ் வந்து எப்படி வரைஞ்சிருப்பேன் அப்படின்னா it is going like this. அப்ப என்ன அர்த்தம் அப்படின்னா அவுட்புட்ல கரண்ட் வந்து கண்டினியூஸ் கண்டக்ஷன்ல இருக்குன்னு அர்த்தம். So when the current is in continuous conduction, it doesn't matter whether you are drawing RL load or RLE load, your output average formula will become same. V naught average, you will be coming up with the same formula. So undoubtedly, that's why I have taken that formula. I have written V naught average equal to Vm by 2 pi into 3 plus cos alpha is common when conduction is continuous. I have drawn the waveform, so I understood that the waveform is continuous. So I have same current will be appearing for battery also. அடுத்த கேஸ்க்கு அதே தான் வந்திருக்கும். If I haven't drawn, but I know. அதனால அதே ஃபார்முலா எடுத்துக்கிட்டோம். When the moment you are facing discontinuous conduction, your formula might be different. Questionல mention பண்ணிருப்பாங்க. In case அந்த மாதிரி question கேட்டாங்கன்னா discontinuous conduction கொடுத்திருப்பாங்க, inductance value is very less or the current is not continuous அந்த மாதிரி கொடுத்திருந்தாங்கன்னா draw the waveform, then calculate the value of V naught average. Otherwise you can go with the same formula. I am repeating one more time. In the question, 3 diode single thyristor is given, and if there will be no any data about the current, then you can take this formula. It is valid. And one more thing is the value of inductance is very high. Like that also they will be giving. Then also you can take this formula. Only case when they are telling that sir the current is not continuous. Only in that case you should draw the waveform, then calculate the value of V naught average. Okay, you should estimate. Take the next question. A three-phase fully controlled bridge rectifier is employed to charge a battery of 95 voltage with the internal resistance of the battery is given and supply voltage is given, output current is given. Just requested to calculate the value of power factor and the value of alpha. Now take your time and drop your answer. You all know, I hope you all know the formulas directly. Just drop the answer. Do it fast. It's a simple question. Don't take much time. Hereafter I'm not going to derive anything because basics almost over. I have shown how to draw the waveform. Three phase at all, it is training session. If I will be starting drawing everything here, our time will be killed. So I will be directly going up with the formulas because it is time to register everything in your brain. உங்களுக்கு என்ன தேவையோ அது ஆல்ரெடி கொடுத்தாச்சு. ஓகே, இதுக்கப்புறம் உங்களுக்கு ஏதாச்சும் தேவைன்னா நீங்க லெக்சரை பார்த்துக்கோங்க. I will be directly going up with the formulas. Okay. But one thing, keep it in your mind. இங்க நான் கொண்டு வர எல்லா ஃபார்முலாஸும் மேண்டிட்டரியா உங்க மைண்ட்ல இருக்கணும். Such that you can save your time in the examination. Almost 98% you can expect the same type of formulas even in the examination also. I know where they will be taking the questions, so I will be covering all formulas. Anyway, it's better to remember the procedure also. நான் ஏதாச்சும் விட்டேன்னா அதை மட்டும் நீங்க கவர் பண்ணிக்கோங்க. Mostly I will be covering, don't worry. So but do remember whatever that I am giving here. Okay. Chalo. Let me solve this question. I will be dropping. Basically, the given question is three-phase fully controlled converter. I hope many of you know the formula to calculate the V naught average. As usual, questionல conduction வந்து continuous இல்ல discontinuous அந்த மாதிரி எந்த ஒரு டேட்டாவுமே கொடுக்கல அப்படின்னா by default you can assume that the output conduction is continuous. And what is the generalized formula for the three-phase rectifier? So the generalized formula is 3 times of VML by pi cos alpha. It is for full control. Okay, this is for fully controlled. If you are controlling off, then what is the formula? For the off control, it will be 3 VML by 2 pi will come. So in the denominator, you must keep 2 also. Okay. Anyway, I will be covering only fully here. Off we will focus later. Fine. So this is the formula to calculate the value of fully controlled rectifier. Sir, why are you writing this? Basically, what is the question is power factor. We are supposed to calculate the value of input power factor. The formula for this one is directly for the three-phase fully controlled bridge rectifier is cos alpha. I do remember. It's better if you also remember, then it will be helpful for you. Okay, I'm repeating one more time. So it is cos alpha. Okay, sir. Next, they will be asking one more question, right? Firing angle alpha also we should calculate. How do I calculate the value of this alpha, sir? So let's see how to estimate this. Given data, we should calculate the value of firing angle also. Okay, sir. இப்போ கொஸ்டின்ல என்னென்ன கொடுத்துருக்காங்க அப்படின்னா, if you observe, battery is given, okay, supply voltage is given, output current I naught is given. Yes sir, just now I told you if the output is RE load, according to KCL, if the output is RE and we know the total output voltage that we are measuring here is V naught, like this. Yes sir, though, so the entering current we can consider it as output current I naught. This is RE. How will you write down the expression for output current I naught? I naught can be written as V naught minus battery E upon R. Yes, so this is how we are simply calculating the value of output current. This is the formula that we are using for RE load and RLE load, because inductor will be short circuited. So RLE also will give you the same formula as per our expressions. Okay, sir. So output current can be written in this way. Yes, it is done. I naught average, and here I am writing V naught average. So this both are done. Okay, sir. Fine. So what is our next task now? Sir, given we are requested to calculate the value of power factor. Yes, of course, we know the value of power factor. It is cos alpha, but how should I calculate it? Think. Is there any alternative way to calculate this value? Voltage is given. Yes, voltage is given. And now check. If the value of cos alpha from here, okay, sir, I just wanted to know this value. According to given data, we can calculate maximum line voltage. What is given? Given it is, first of all, listen, RMS voltage and RMS, the two per phase voltage they told. Line to neutral only they told. I told this is line to neutral, means per phase voltage. Given it is RMS only, but there is per phase voltage. So 240 voltage RMS. But I want a maximum voltage first. So let me convert this value from maximum per phase voltage. This is RMS per phase is given. Maximum per phase means root 2 times of 240. Next, all our circuits here we are considering by default we are considering only star connection. So in case of star connected network, we know line voltage will be equal to root 3 times of phase voltage. Next conclusion. I just wanted to know the value of maximum line voltage. So here I am having maximum per phase voltage. So I can write line maximum voltage. So maximum line voltage will be equal to root 3 times of maximum per phase voltage. Yes or no? Yes, sir. So maximum per phase voltage is root 2 times of 240. Root 2 into root 3 will become root 6. So I can substitute it is. This is going to be root 6 times of 240 voltage. Yes or no? Yes, sir. So now I can substitute here root 6 into 240 finally. So very careful while solving the problems. Okay. Now, is there any possibility to calculate the value of V naught average? See there. சம்பந்தமே இல்லாத ஒரு ஃபார்முலாவை இங்க எழுதுனீங்களே, அது எது தேவையா இங்க? Yes, my mind was blinking with that. That's why I wrote that formula. ஏன்னா அவுட்புட் கரண்ட் கொடுத்துட்டாங்க. இது எவ்வளவு கொடுத்துருக்காங்க பாருங்க, 50 ஆம்பியர். ரெசிஸ்டரோட வேல்யூ பார்த்தா அதையும் கொடுத்துட்டாங்க. கொஸ்டின்ல தான் இங்க பாருங்களேன், இதையும் கொடுத்துட்டாங்க. பேட்டரி வோல்டேஜ் அதுவும் தான் கொடுத்துட்டாங்க, 95. So if you substitute all these parameters, directly you can calculate the value of V naught average from here. So let me estimate. Output current is given as 50 ampere equal to V naught average is not known minus battery voltage is 95 divided by internal resistance is 0.2. I can say V naught minus 95 equal to, I think 0.2 into 50 will be 10 voltage, right? Yes, of course I'm correct. From this I can say V naught equal to 10 plus 95 will become 105. So we got the value of V naught average. So this is going to be 105. Let us reduce. So from this what we can say, to keep cos alpha one side, reduce all other expressions. So first 3 into root 6 into, we have to multiply it by 240. Then I am dividing it by pi such that I got. So here right side we are having 105. In the left hand side we will be having 561.38 times of cos alpha. So from this the value of cos alpha will be equal to, we should take reciprocal for this and multiply it by 105. So 1 minute guys. So we have to take 105 divided by 560, 1.38 will be getting 0.187. 0.187. So this is the value that we got for cos alpha. It is very poor value, I know. From this the value of alpha, if we take cos inverse for this, we'll be getting almost 79.219 degree. I know this is very vast value. It is almost near to the value of 90 degree. So when we are getting close to the value of alpha value 90 degree kitta ponale output la voltage and automatically reduced. See there we are receiving only 105 voltage, but we have injected 240 voltage. The reason is the value of alpha is very large, almost it is equal to 90, and it is getting close to it is 80, it is getting close to 90 degree. So when the value of alpha is approaching to 90 degree, when it is getting close to 90, automatically V naught average will be started reducing. You can see all these things in our lecture. I have been explaining everything step by step. If you see our lecture, very few part if you observe, that itself you will get the idea how to draw the waveform, because I have been done everything step by step. So it's better to watch it once. Okay, that will be helpful for you all. Okay, so when the value of alpha is given 80 degree, so when the moment we are giving 80 degree, so now we can substitute all these values. We will be calculating the value of, yes, so alpha became 80 degree. Guys, do remember one more thing, alpha is not crossed 90 degree. When alpha goes beyond 90, then case will be different, output voltage will become completely negative. But still we haven't reached that portion, we are in 80 only, we are about to touch 90 degree. Okay, so it will not be that case, it will not be discontinuous. Do remember, it is already they told in the question, it is constant. Constant means what? It is continuous. So we have estimated this value. See, power factor is very poor, it's only 0.1, very very poor I can say. Fine, sir. So this is all for this lecture. Oh, sorry, this is all about this question, not for this lecture. Chalo, let us go ahead with the next question. I'll be bringing the next question is what they told is a following sketch. See, we will be considering a three-phase fully controlled converter. As usual, a three-phase fully controlled converter, average output voltage. They are talking about V naught average voltage for the various firing angle. For what they are asking you is you should draw the output waveform when alpha equal to 0 degree for the three-phase fully controlled converter. When alpha equal to 0 degree, how your waveform will be looking like. When alpha equal to 60 degree, how your waveform will be looking like. When alpha equal to 150 degree, sorry, let me cover one more value. When alpha equal to 90 degree, then how your waveform will be looking like. When alpha equal to 150 degree, then how your waveform will be looking like. So this is the generalized question. For a three-phase fully controlled rectifier, we can directly draw the waveform. So when alpha equal to, let me draw the waveform. When alpha equal to 0 degree, you will have a ripple, almost a ripple free voltage. This is how your waveform will be looking like. Guys, you can observe all these things in our lecture. Okay, there is nothing too new to observe here. You can just recapture it. When alpha equal to 60 degree, your waveform will be like this. I do remember, so I'm directly drawing the waveform. It will be going like this, a straight line again, a straight line again. Okay, if I will make the LF alpha equal to 90 degree, almost we will be getting, now we will be started receiving negative voltage, right? 60 degree க்கு மேல போனாலே என்ன ஆகும்? Till 60 degree இப்போ நீங்க அப்சர்வ் பண்ணீங்கன்னா see கரெக்டா 60 degree வரும்போதெல்லாம் 0 டச் பண்ண ஆரம்பிச்சிடும். அது வரைக்கும் பாசிட்டிவா இருக்கு. இப்போ கவனிச்சீங்கன்னா alpha equal to 0 degree, voltage is positive. Now I am increasing the LF alpha slowly till alpha equal to 60, your voltage will be positive. At least it is crossing 0, again it will be positive. But when the value of alpha will become greater than 60 degree, you will be started receiving negative portion also. So it will be coming like this. Then you will be observing, then again a straight line, again it will be negative portion, a straight line, again negative portion, a straight line, again negative portion. It will be going like this. Suppose if you are making alpha equal to 150 degrees, just think about this situation, everything will goes negative, right? So the entire portion of the waveform, it will be lies under, let me draw here. See, this is positive portion, you will be in negative zone. Your waveform will be almost, wait, I think, yeah, I'm drawing correct waveform. Almost your waveform will be in negative zone. Just observe how to draw the three-phase waveforms. It's in our lecture, you can easily understand. It's not a big deal to do. Okay, so I hope you understood this. Just have a recapture it. நம்ம த்ரீ ஃபேஸ் வந்து ஃபுல் பிரிட்ஜ் வேவ் ஃபார்ம் வரையும்போது இதெல்லாம் நம்ம ஆல்ரெடி பண்ணியிருப்போம். ஸோ இட்ஸ் நாட் அ பிக் டீல் டு டூ. Just recapture it. Okay. Chalo, let us go ahead with the next question. So let me take a single phase semi converter. A single phase semi converter. As usual, what it is doing is it delivers power to RLE load. It delivers power to RLE load. Yes, in delivering power to RLE load. Whereas the value of R is given as 5 ohm. Under the value of L, as usual, it is given as 5 millihenry. It is 5 millihenry. Come on. Under the value of battery E is given as 100 voltage. Everything is given. AC supply, single phase semiconductor, AC supply value is given 120 voltage as usual, undoubtedly. Frequency, same, Indian standard frequency, Indian system, it is 50 Hz. Now the question is, they are told it is having continuous conduction. It is having continuous conduction. Conduction is continuous. The average value of the output current is dash. The value of average value of output current will be dash, whereas the value of alpha is clearly given as 45 degree. Take your time, drop your answer. Don't take much time. I'm expecting your answer. Do it as speed as possible. You can take 2 minutes because it is very easy question. If you don't know the answer, no problem. I will be dropping the answer. Don't worry. Single phase semi-controlled converter. You know, semi-control means 2 diodes, 2 thyristor will be there. What can be the expected V0 average? Draw the waveform. Listen, ஒரு விஷயத்தை understand பண்ணிக்கோங்க. Just for your understanding, recapture the things. I have drawn the waveforms for first 2-3 classes. But it is time to explore everything by yourself. நீங்களே உட்காந்து output waveform வரைங்க. Learn it. Then only you will be in the top rank. ஸ்லோலி என்ன ஆகிடும் அப்படின்னா ஒரு ஒன்லி வந்து இப்போ நீங்கள் ஒரு 500 ஃபார்முலா பவர் எலக்ட்ரானிக்ஸில் பார்க்குறீங்கன்னு வச்சுக்கோங்களேன். அதுலேருந்து ஒரு 30லேருந்து 40 ஃபார்முலாஸ் மட்டும்தான் வந்து ரிப்பீட்டடாக வந்து எக்ஸாமில் கேட்டே இருப்பாங்க. அதையும் தாண்டி ஒரு சில விஷயங்கள்லாம் தேவைப்படும். அது எல்லாமே மைண்டில் ஸ்டோர் ஆகிடும். நீங்கள் நிறைய கொஷின்ஸை சால்வ் பண்ணிகிட்டே இருக்கும்போது என்ன ஆகிடும்னா ஒரு டைமுக்கு அப்புறம் எவ்ரி திங் வில் பி இன் யுவர் மைண்ட். That 500 formula is not required first of all. By practice, you will understand. Experience is required for that. Chalo, what is the answer? Drop it. I don't know whether you people are working on it or not. So let me shall I do it? Okay, gowning. Sir, given it is a semiconductor, of course everything is fine as usual. The question is, what is the I0 average? What type of question it is? What type of load first of all? Given it is RLE load. RLE load. RLE load means resistance, inductance, battery will be given, and we will be observing the voltage across this whole terminal. But what did I told you? I told you when DC supply is connected in series with the inductor will be behaving as a short circuited one. So we can draw its equivalent circuit like this. You can consider one resistor and one battery. Simply 1.547 ampere. Geeta, very good. I think see what other people are doing. See, one thing you have to understand, it doesn't matter whether you people are getting correct answer or wrong answer. நீங்க எவ்வளவு நேரம் கண்டினியூஸா ட்ரை பண்ணிட்டே இருக்கீங்களோ that is your success. Do remember that. I told you at last you all will be filtered out. I will give special training. எக்ஸாமுக்கு முன்னாடி உங்களுக்கு என்ன தேவை அப்படிங்கிறது I know very well. That things will be given to you. If you want that, do it properly. Keep your attention here. Okay, how will you write the expression for from this? We can write output current I naught equal to as usual V naught minus battery voltage E upon resistor R. I naught average is required. So if you want to know the value of I naught average, see there. Then V naught will become V naught average. V naught will become V naught average. Battery voltage is given. Now substitute all the values. So what is the V naught average first of all? How will you calculate the value of V naught average for this single phase semi converter? I know you all know the formula for this. It is standard formula. It is very important too. Vm by pi into 1 plus cos alpha. It's not a big thing to memorize. You can easily remember it. So now here, what is the maximum voltage? Maximum voltage root 2 times of supply voltage. Supply is given 120 upon pi into 1 plus cosine 45 degree. Cos 45 is 1 by root 2 as usual. So 1 by root 2 equal to 0.707 plus 1. So 1.707. Now let me reduce it. Root 2 into 120 into 1.707. So we will be dividing it by pi. What you'll be getting is 92.21 voltage. So this is the value of V naught average we got. Next, it is time to explore the value of output current I naught. So the value of I naught average will be equal to Sadhana Shankar 16.3. Very good. So the V naught average what I was getting is 92.21, whereas the battery voltage they had given us 100. Good. See there. I'll be getting negative answer. It means battery is delivering the power. So well, let's try to estimate because see they haven't mentioned the direction of the current. So அதனால வந்து நீங்க current நெகட்டிவ்ல சப்ஸ்டிட்யூட் பண்ணணும்ன்ற அவசியம் கிடையாது. You can reverse the direction. பேட்டரியோட V naught average calculate பண்ணதுக்கு அப்புறம் actually I was putting V naught minus E because I am observing usually current will go here in this direction. But why it will go in this direction means the value of V naught is greater than the value of E. That case is correct. Now you should think, okay sir, suppose if I am getting battery voltage is, suppose if the case is reversed, if E is greater than V, then what will happen? Just reverse the direction of current. Then write down like this, the value of output current I naught can be written as E minus V naught by R. That's all. This is a twist in the question, right? So what you can do is I'm interchanging the position. I'm considering what you can do is, let me write here. I naught average will be equal to battery voltage is 100 minus V naught average we are getting 92.21. Be careful with the numerical values. Don't blindly follow me. I'm repeating. I'm giving only ideas here. Don't follow everything blindly. Just what I'm doing here. Do it by yourself. Verify whatever the things that I'm doing is correct or not. Then you can keep it yourself. Yeah, the correct answer is 1.558 ampere. And the direction of the current is getting reversed. Let me ask you one more question. Now tell me whether the battery is delivering the power or absorbing the power here. How will you identify it? So if your source is delivering the power, then the direction of the current will be like this. Current entering point is minus, leaving point is plus. Suppose if the source is absorbing the power, then how will be the direction of the current? Current entering point will be plus, leaving point is minus, like this. So directions both are in opposite each other. So you can easily identify. In the first case, it is delivering the power because this is the given basic networks. In the second case, it is absorbing the power. Now, if you take our question, what is the case happening here? So in our case, battery is delivering the power. Why? We know just now we found that the value of battery voltage is higher than the value of V naught average. So the battery is delivering the power. What is the power delivered by the battery? It is simply the product of battery voltage into current delivered by the battery. What is the value of battery voltage? It is 100. What is the current delivered by the battery? 1558 ampere. So it will be 155.8 watts. This is the power delivered by the battery. That's all. So this is how we are doing these calculations. Okay. Now what is the power dissipated across the resistor? or power absorbed by the resistor. So it will be simply current flow through the resistor into R. How will you calculate the current? Current, we know current flow through the resistor is 1558 square times into the value of the resistance is how much? 5. Now you have to 1558, if you square then you should multiply it by 5. So I can say the power absorbed by the resistor is 12.1368 watts. This is the power absorbed by the resistor. Yes or no? This will be correct. Fine, sir. So this is how we are doing the calculations for the semi-converter. Sure. Let us take the next question. So what happened is, let us take a single phase. Once again, we will take full controlled converter. Fully controlled converter, a single phase fully controlled converter. I am considering full controlled converter is feeding RLE load. A fully converter is feeding RLE load. Okay, sir, it's feeding RLE load. And what they have given is source voltage Vs equal to, as usual, 120 voltage, and the frequency of same data 50 Hz. Undoubtedly, this is the given. Okay, sir. Now in the load side, they have shared the data for the RLE load. The value of R is given as, you can take 4 ohm, and the value of inductance L is given as 10 millihenry. Value of the battery is given as 25 voltage. This time they have reduced the voltage. 25 voltage RLE load. And firing angle alpha is given. The firing angle alpha equal to 30 degree. We can consider the firing angle alpha equal to 30 degree. Now the question is the average value of the output current and the output voltage in case load current is extinguished. Listen. What is the value of I naught average and V naught average if output or load current, if output or load current, just observe this word extinguished. It is very important. Extinguished at omega t equal to 200 degree. That's all. Understood? Spend some time. Question என்ன சொல்லிருக்காங்கன்னு first understand பண்ணிக்கோங்க. எக்ஸ்டிங்ஷனை பத்தி நம்ம ஏற்கனவே பேசியிருக்கோம். எக்ஸ்டிங்ஷன் அப்படின்ற ஒரு வார்த்தையை நான் ஆல்ரெடி யூஸ் பண்ணியிருக்கேன். அதுக்கு நான் ஒரு பேர் கூட வச்சிருப்பேன் அந்த எக்ஸ்டிங்ஷன் ஆங்கிளுக்கு. பேசிக்கா வந்து எக்ஸ் ஆக்சிஸ் வந்து நம்ம ஒமேகா டீல தான் ரெப்ரசென்ட் பண்ணுவோம். தட் ஈக்குவல் வேல்யூ இஸ் தீட்டா. டிகிரில இருந்தா தீட்டா தான். ஓகே. அந்த எக்ஸ்டிங்ஷன் ஆங்கிள் அப்படிங்கிறது என்ன, இங்க என்ன சொல்ல வராங்க, இந்த மாதிரி ஒரு சர்க்யூட்டுக்கு நம்ம எப்படி வந்து V naught average கால்குலேட் பண்றது, அவ்வளவுதான். ப்ரொசீட் பண்ணுங்க பாப்போம். இட்ஸ் குட் क्वेश्चन, ரைட்? இட்ஸ் ரியலி வெரி குட் क्वेश्चन. ஸோ RLE லோடு வரும்போது, இந்த மாதிரி கேசஸ் வரும்போது வாட் ஷுட் வி டூ? எக்ஸ்டிங்விஷன் அப்படின்னா என்ன? ஃபர்ஸ்ட் ஆஃப் ஆல் ஃபுல் கண்ட்ரோல் ரெக்டிஃபயருக்கு உங்க எல்லாருக்கும் காமனான ஃபார்முலா தெரியும், அதாவது ஜெனரல் ஃபார்முலா. எப்படி எழுதுவீங்க? ஜெனரல் ஃபார்முலா V naught average single phase fully controlled அப்படின்னா we can directly write that 2Vm by pi into cos alpha, sir. That is correct. And I told that formula is common for all type of load when the conduction is continuous. Continuous conduction அப்படின்னா கரண்ட் எங்கேயுமே என்ன ஆகக்கூடாது, எக்ஸ்டிங்விஷ் ஆகக்கூடாது. எக்ஸ்டிங்விஷன்னா மீனிங் என்ன? நம்ம வந்துட்டே இருக்கோம், திடீர்னு வந்து நம்ம வந்து காணாம போயிடணும்னு அர்த்தம். அதான் வந்து எக்ஸ்டிங்விஷ் ஆகுறது, வெளியில போயிடுறது, ஃபீல்டை விட்டு வெளில போறது. அவங்க எக்ஸ்டிங்விஷ் ஆகிட்டாங்க, எக்ஸ்டிங்ஷன், இட்ஸ் ஓவர், ரைட்? ஸோ இப்போ நான் வந்து கரண்ட் வந்து கண்டினியூஸாக ட்ராவல் பண்ணிகிட்டே இருக்கு, ஜீரோல இருந்து அப்படியே வந்துட்டு டக்குன்னு பார்த்தா ஒரு டிகிரியில் டிஸப்பியர் ஆகிடுது, ஒரு வேல்யூ வந்து ஜீரோ ஆகிடுது. தட் இஸ் வாட் தே ட்ரைங் டு மீன் தேர். அப்போ அந்த மாதிரி ஒரு RLE லோடில் அந்த மாதிரி ஒரு டிஸ்கன்டினியூஸ் கண்டக்ஷன் வந்தால் V நாட் ஆவரேஜ் ஃபார்முலா. RLE லோடு கண்டினியூஸ் கண்டக்ஷனாக இருந்தால் இட் இஸ் generally 2m by pi cos alpha only. I hope you all know that. If it is discontinuous conduction, then how would you express it? Output waveform வரைங்க, வரைஞ்சிட்டு அதுக்கப்புறம் என்ன பண்றீங்கன்னா, okay, do one thing, listen. It will be taking some time for you guys. My sincere suggestion, after at the end of the lecture, sit and draw the waveform for this given data diagram. Input waveform கொடுத்து பேட்டரியை கன்சிடர் பண்ணி, நான் ஆல்ரெடி ரஃபாக வந்து நம்ம லெக்சர்லேயும் இருக்கும், நான் இப்போ கூட சொன்னேன், பேட்டரி வந்துச்சு அப்படின்னா நம்ம எப்படி வேவ்ஃபார்ம் வரையணும். நம்ம முன்னாடி ப்ராப்ளம் சால்வ் பண்ணும்போது கூட நான் கிளியராக எக்ஸ்பிளைன் பண்ணேன், பேட்டரி வந்ததுன்னா நம்ம எப்படி வந்து எக்ஸ்பிரஷன் கொண்டு வரணும் அப்படின்ட்டு. ஸோ ஜஸ்ட் டு ட்ரை டு ட்ரா தி வேவ்ஃபார்ம், then estimate the value of V naught average. I will be writing the formula directly. See, it is clearly given that the conduction is discontinuous. Sir, discontinuous எப்படி சொல்றீங்க? How do you know that? Yes, I know. They told that this current is extinguished at omega t equal to 200 degree. நம்ம என்ன பண்ணுவோம் அப்படின்னா, இன்புட்ல வந்து ஒரு சைனசாய்டல் வேவ்ஃபார்ம் will be injected up to 360 degree. Yes or no? So over a period of this time, what might happen is current is continuously going. After, when it is reaching 200 degree, the value of current will become 0. Again, what will happen for the next up to 360 degree, current will be 0. Almost it is for 160 degree current 0 இருக்கு. திரும்ப after 360 again current will be continuous. Then again when it is reaching one more 200 degree, again it will be almost 560 degree, once again it will be 0. So it will be current. See, if you observe, between for the 160 degree current will be 0 ampere. This is called discontinuous conduction. Extinguishing means that is called extinction angle. Extinction angle அப்படின்னா in which current will become 0, output current will become 0. That is called extinction angle. Okay, current extinguished ஆகுதுன்னு அர்த்தம். ஓகே சார், ஃபைன். அப்போ கண்டினியூ பண்ணலாமா? இப்போ V naught average இந்த மாதிரி கொஷின்ஸ் வரும்போது வாட் கேன் பி எக்ஸ்பெக்டட் ஃபார்முலா டு கால்குலேட் தி V naught average when the current is discontinuous? So let me write, it will be 1 by pi in bracket, I'm recapturing, it should be Vm into okay cos alpha minus cos times of beta plus here we having E into 180 plus pi. Yeah, it should be pi plus alpha minus beta. Yes, I'm correct. Definitely it will be correct. Now you can substitute all the data. See guys, this is maximum voltage. RMS voltage is given 120, maximum voltage means multiplied by root 2. Next, alpha is given as 30 degree, you can directly substitute alpha equal to 30 degree. Beta is given, that is called extinction angle, it is 200 degree. Battery voltage E, that is also given, yes or no? Yeah, it is given, that is 25 voltage. Pi again alpha, listen. Here we are having one value in radiant, here the value of alpha and beta should be in radiant. Sir, அப்போ ஏன் cos of alpha டிகிரியிலே சப்ஸ்டிட் பண்ணுறீங்க பீட்டாவுக்கு? பிகாஸ் வாட் ஹேப்பன் இஸ், நீங்கள் cos of alpha வந்து வேல்யூ டிகிரியில் சப்ஸ்டிட் பண்ணும்போது இதோட ரிசல்டன்ட் வேல்யூ will be in radiant only. That's why I am substituting it directly. Other things you should not keep. So now you can substitute. So the value of alpha, what should be? The thing is, so if I will consider the value of alpha, it is in degree. How will you convert it into radiant? Multiply it by pi by 180. Similarly, if you consider beta, beta is what? Beta will be once again 200 into pi by 180. Now everything is in radiant. Reduce this expression, we will be getting the value of V naught average. This is for discontinuous conduction of the single phase, fully controlled. When our RLE load, when our conduction is not continuous. Fine sir, this is fine. How do I calculate the value of V naught average? As usual, same formula. What same formula? I told now, RE load, RLE load. Again, same resistor, then battery. If you calculate the V naught average, if the value of V naught average is greater than E, then how will you write down the expression for current output? I naught can be simply written as V naught minus E by R if the value of V naught is greater than E. Otherwise, in the last case, when we are solving the last question, what we saw, there are two cases. Suppose if the battery is delivering the power, then the direction, how will you write the output current? It can be written as E minus V naught by R. That's all. So write this just now. Here you will be calculating the value of V naught. Substitute it here. And what is value of battery voltage? It is given as 25. What is value of resistor? That is given as 4 ohm. You will be getting the value of current. Good, Geeta. Yes, ma'am. Thank you. She got the answer 24. Let me substitute here. See if it is correct. You all guys can cross check. I am taking that value. Suppose if this value is correct, see there once again battery value is higher than the value of output voltage. So you will be substituting this value here. It will be what? 25 minus of 24 will be 1, right? So 1 by 4, yes, it will be equal to 0.25 ampere. Very good. See, I don't know whether this is correct or not. You guys can cross check because every one of you are having calcium and you do this. Do it and cross check once. Try to keep your answer here. Okay. Fine, sir. So, let us go ahead with our next most beautiful question. Let us keep our attention with the next question. Okay. 1 second. Let me bring the question first. Yes. What is the question is? The question is, we are considering SCR. Okay, silicon controlled rectifier. SCR is there and they told that this SCR is having peak forward voltage BPF and this voltage they have given as 1800 peak forward voltage. Do remember, I am repeating, this is peak forward voltage. Next, and average on-state current rating of the thyristor is average current rating is given as 100 ampere. Average thyristor rating is used in single phase midpoint converter. This data they are using this see given it is nameplate details of the SCR. This SCR is used to design midpoint converter. You all know the meaning of midpoint converter. Midpoint converter and a single phase bridge converter also. It is also used to design full bridge converter. Design bridge converter. So both things can be done. Now they told that use a safety factor. I know many of you guys are struggling here. Let me clear this one also. In some cases you will be noticed that the safety factor is given. So whenever safety factor will come, what should I do? So that things will be cleared now. Don't worry. So safety factor is 2.5. Now the question is, what is the power delivered by the above two cases or power absorbed by the loads in both of these cases? The power handling of the two converters, we can say the power, the decent word is the power handled by two converters respectively. Two converters or dash respectively. You can write that word if you want. Let me tell you the question first. First, they have given the nameplate details of the SCR. With the help of this SCR, they are trying to build two type of converter. One is single phase fully controlled midpoint converter. Another one is single phase fully controlled bridge converter. And they have given the safety factor value as 2.5. Now, what is the power that can be handled by these two converters? இவங்களால எவ்வளவு பவர் வந்து இந்த டிவைஸ் கொடுத்திருக்க டேட்டா வச்சு வந்து அவங்களால ஹேண்டில் பண்ண முடியும்? What is the power that can be delivered through இப்போ மிட் பாயிண்ட் கன்வெர்ட்டர் இருந்தால் எவ்வளோ பவர் வந்து அதில் டெலிவரி ஆகும், அதே மாதிரி பிரிட்ஜ் கன்வெர்ட்டர் இருந்தால் எவ்வளோ பவர் வந்து டெலிவரி ஆகும்? That is the most beautiful question that is given in your question. You can try. பவர் ஹேண்ட்லிங்னா என்ன? நத்திங் இஸ் தேர். வி நாட் அவுட்புட் பவர் எவ்வளோ பவர் வந்து டெலிவரி ஆயிருக்கா அதான் அதெல்லாம் டெலிவரின்னு எழுதுனேன். பட் சம்டைம்ஸ் தே வில் பி யூசிங் தட் ஹேண்ட்லிங். யூ வில் பி கன்ஃபியூசிங். இது என்ன ஹேண்ட்லிங்னு புதுசாக இருக்குன்ட்டு both are same. You can keep output power only they are telling in this way. Calculate the output power in both cases. That's all. Guys, you can take your time. You can spend your time. Okay, I'm giving this question. I'm leaving it as a homework question because I know some of you guys are having a doubt at this point. சரிங்க என்ன சார் பண்றதோ சேஃப்டி ஃபேக்டர் வந்து 2.5 கொடுத்துருக்காங்களே. Just think somehow. Okay, do something. Try to figure out the answer. You can't find the answer for these questions whatever that I'm dropping anywhere. I already told you. Okay, so try to do it by yourself and drop your answer in the group. You can discuss with your friends. I have done this way, I got the answer. What about your answer? Just compare it, don't do anything else apart from that. Okay, so this is all for this lecture. In the next session, first we will be solving the question for this, sorry, we will be solving this question, but I'm expecting your answer. At least try to learn what is the safety factor. Okay, do one thing, first learn what is the safety factor. Safety factor அப்படின்னா என்னன்னு first learn பண்ணுங்க. Definition of safety factor. One more thing, safe operating area இப்படின்னா என்ன, just learn these two. And how this safety factor is influencing thyristor, learn it. How this safety factor is influencing thyristor. If safety factor is given, what to do with the thyristor, learn these basic things. If you figure out the answer for this question, automatically answering this question will become very easy. That's not a big deal. I don't think that will become difficult once you figure out the answer for this. Okay,